Hello, I'm Daniel Fritz, again coming to you from Daniel Fritz Mathematics, and today we're going to be talking about marginal cost or marginal analysis dealing with business calculus. And this is a very, very important calculus series for business people and also those who are going into human resources or any type of industrial technology dealing with manufacturing. So let's look at marginal cost, revenue, and profit cost, right? Let's look at some formulas here. So marginal cost, revenue, and profit if X is the number of units of a product produced in some time interval, then so total cost is represented by C sub X. The marginal cost is C prime of X, which is its derivative. You have the total revenue, which is R sub X, and the marginal revenue is equal to R prime of X, which is also its derivative of dealing with the revenue function. The total profit is P sub X is equal to R sub X minus C sub X, which entails that the marginal profit for this is its derivative, where you have P prime of X is equal to R prime of X, and C prime of X, which is the marginal revenue minus the marginal cost function. Now the marginal cost, or the revenue or profit, is the instantaneous rate of change of the cost or the revenue or profit relative to the production of a given production level. Now sometimes when you actually are selling or creating a unit or creating units to sell for revenue, you have to measure the acceleration of revenue that is developing over time. The revenue is building up funds or monies over a specific time. So depending upon how fast that happens, of course, is the derivative. Finding out the rate of change and how fast, or that profit function or that revenue is actually building up over time, or God forbid, hopefully not decreasing over a certain amount of time. So we all want our revenue to increase over time. So let's look at cost per unit though. The average cost is equal to C bar sub X, which is, now C bar sub X is the cost function divided by X. And its marginal average cost is C bar prime of X, which is equal to the derivative of C bar of X, which is respect to X. Now the revenue per unit is the average revenue. The average revenue, which you got R bar sub X is equal to the revenue function, or R sub X divided by X. And you have the marginal average revenue, which is R prime of X is equal to the derivative of R bar sub X. Very important. So then how about the profit per unit? And you have average profit, and P bar sub X is equal to P sub X divided by X, as you see. And the marginal average profit is P bar prime of X. P bar prime of X is equal to the derivative of P bar sub X, which is also respect to X. Now that we said those things, let's kind of get a nice zoom, a close shot of these formulas here and these representations here and also over here as well. And we will talk about the application of some of these functions in just a few minutes. So those are my class, my students, get this information, copy this information. You are free to stop the video and copy the material and start it again. or rewind or fast forward. And people all over the world, you are welcome to get this as well. Great, so let's look at a problem dealing with cost analysis. So for cost analysis, a small machine shop manufactures drill bits used in the petroleum industry. And the manager estimates that the total daily cost in dollars of producing X bits is the cost function here, C prime, no, not C prime, sorry. C sub X, this is the cost function, not the marginal cost, not yet, but C sub X, this is just the cost function. C sub X is equal to 1,000 plus 25X minus 0.1 X squared. Now, watch this. We want to find C bar sub X and also C bar prime of X. So we want to get the marginal average cost, its derivative, and then B, we want to find C bar of 10 and also C bar prime of 10. So we want to substitute the value of 10 into the equation C bar, and also after that we want to also substitute the value 10 into the derivative once we find the derivative of C bar. And then we want to interpret these quantities. And then C, use the results in part B to estimate the average cost per bit at a petroleum level of 11 bits, sorry. We want to interpret or estimate the average cost per bit at a production level of 11 bits per day. Yes, there we go. It's a little bit, getting a little bit tired here, so bear with me. So, okay, so A, let's look at A. C bar of X is equal to C sub X divided by X. This is the function here, the cost function. And that's going to be divided by X, as you see. So when we divide that by X, we come up with 1,000 over X, plus, the X's cancel out there. And then we come up with just 25 minus 0.1 X. Now, with that, we want to find the derivative. We want to find the derivative of, make sure I written this out correctly because we don't want to do this wrong. We want C, we want the derivative of C bar prime of X. There we go. We want to find the derivative of that. So when we take the derivative of that with respect to X, we come up with negative 1,000 over X squared minus 0.1. And so when we do that, first, we want to take 10, the value of 10, and plug it into this function first, which is just C bar. See C bar? C bar is right here. So we want to take and plug that in, or substitute 10 in where the X is, right? So 1,000 divided by 10 plus 25 minus 0.1 times 10 is going to give us $124 for that calculation. $124. So now we want to find C bar prime of 10. C bar prime of 10 is going to be this. C bar prime of 10. And that's going to be that's actually, like I said, the derivative of C bar. That's the derivative of that, just like here. So when we find C bar prime of 10, it's going to be minus 100 divided by 10 squared minus 0.0, and that's going to give us negative $10.10. So here's the deal. When we talk about that or interpret this, at a production level of 10 bits, per day, the average cost of producing a bit is $124. But the cost is decreasing at a rate of $10.10 per bit. As we see that. Let's zero in on that right there. So it's zero here. So we can do zero in. We see that that is the interpretation of that. Remember, this is C bar prime, which is the derivative. Now let's look at this, the derivative of what? C bar of x. That's the derivative of C bar of x. Everybody see that? C bar prime of x is the derivative of C bar of x. And I just wanted to make a note of that. Okay, that's very, very important. I want to leave nothing out. Okay? Now, let's look at C. Let's interpret C. Okay, use the results from part B to estimate the average cost per bit at the production level of 11 bits per day. So if the production is increased by 1 bit, then the average cost per bit will decrease by approximately $10.10. So the average cost per bit of a production level of 11 bits per day is approximately 124 minus $10.10, which is going to equal to $113.90. Now, this is the cost analysis here. If you can take a good look at this and make sure everybody in my class and everybody all over the world, if you want to see this, and copy this down, make sure you make these few corrections here. Just want to make sure that those are understood to be what they are. This is C bar prime of x, which is the derivative of C bar. So take a second to zoom in on that, and then we're going to go to another problem in just a second. Okay, so let's talk about revenue function, marginal revenue function. So suppose the relationship between a unit price, P in dollars, and the quality demanded X of a Acrosonic Model F loudspeaker system is given by this equation. P is equal to negative 0.02x plus 400, which you have the interval from 0 less than or equal to x less than or equal to 20,000. So we start by the analysis. And we want to have the revenue function R is given by R sub x is equal to P times x. So P is this function here. So we place that there for P, and then we times this by x. So when we distribute the x to the function, to this expression, we'll get negative 0.02x squared plus 400x. And so the marginal revenue function R prime is given by the derivative of this. It's the derivative, so we're going to come up with negative 0.04x plus 400. Now, that's the derivative of the revenue function. Now, what is R prime? Let's see, R prime at 2,000, right? The value of 2,000. So when we do 2,000, R prime is going to be R prime 2,000 is equal to negative 0.04 times 2,000 plus 400. Plus 400, yes. And so that's going to equal to 320. So thus the actual revenue to be realized from the sale of the 201st loudspeaker system right? The 201st loudspeaker system that is produced is going to be $320. So everybody see this. So get a good shot of that. Okay, so let's look at number 3. We're going to look at marginal profit function, right? Marginal profit, which refers to, we're going to refer to a little bit of example 2's analysis. And suppose the cost of producing X units of equisonic models as loudspeakers. We have a cost function of 100x plus $200,000, right? This is the model, and this is in dollars. So we want to find the profit function P. We want to find the marginal profit function P prime. And we want to compute P prime of 2,000 and interpret its results. Now, watch this. R sub x is equal to, and this is from the example 2. If you see example 2 here, we have the profit function. I'm sorry, the revenue function, which is this here. This is the revenue function. What I'm boxing off here from example 2, and this is what this is right here. So this is the same thing from example 2. Here, negative 0.02 x squared plus 400x, and thus the required profit function P is given by, here we go, P sub x is equal to R sub x minus C sub x. Now always be careful when you actually take the revenue function minus the profit function. When you're simplifying this, make sure, a lot of students make this mistake, is that they don't distribute the negative sign to each of the terms of the cost function right here. So it's very important that you do so, right? So here, once you do that, and of course you see the work that I'm showing here, you're going to come up with negative 0.02 x squared plus 300x minus 200,000. So that is your profit function right here. Your profit function is equal to this right here. There we go. My negative sign wasn't blue, but I was going equal sign, kind of went over it, so I went on ahead and put the negative sign in red. So that's okay. So this is the negative sign. Zoom in there. Make that a little bit neater. Profit function is equal to that's our negative sign. There we go. So our marginal profit function, right, our marginal, that's the derivative of the profit function, is going to be P prime of x is equal to negative 0.04x plus 300. That's your derivative. Now what the marginal profit function is, this derivative at 2,000 is going to be negative 0.04 times 2,000 plus 300, and that's going to equal 220. So thus the actual profit realized from the sale of the 2001st loudspeaker produced there is approximately $220. Well, this concludes the business calculus portion of the video. And if you have any questions, of course, you can always subscribe to Daniel Fritz Mathematics, and also stop the video. You can rewind and you can fast forward and pick up any things that was missed on the video. You can pick it up. And I want everybody to have a nice day. Hope this helped.